Looking at the cycle of what we're using when we're cleaning or disinfecting. Where does it go when we're using disinfectant? First, it's being used. Once it's been used, some of it will stay on surfaces. For some type of products, part of it will go in the air, and most of it will go in the sewage system after rinsing or throwing down the drain, excess cleaning or disinfecting solution. When it goes to the sewage system, it's not disappearing. Maybe it's disappearing from our site, but it goes somewhere. It goes to the wastewater treatment plant of your community. But after the wastewater treatment plant, it goes somewhere else as well. It goes to the natural environment. It can be a river, a lake. And when it gets there, it's coming back into our drinking water. So it's really a cycle. You know, we use water to manufacture cleaning products and disinfectants. We use them, they're disposed, they go down the sewage, the wastewater treatment plant, it goes back to the environment, and then it's coming back into our drinking water. Most communities have a wastewater treatment plant. Fortunately, most of them are biological wastewater treatment plants. You have the biological systems and you have the chemical-physical system. Chemical-physical systems are not biodegrading anything, it's just flocculation, sedimentation of solid particles, and they're not very good system, but unfortunately they still exist. What we call the biological wastewater treatment plants, they're basically bioreactors. They are aerated ponds or other systems where you have a high concentration of microbial biomass who are feeding on any type of substance that's arriving in the wastewater. The ultimate goal is really to biodegrade the organic matter and even the chemicals that are entering the wastewater treatment plant. It's collecting water from every houses in the community, from industries, from schools, from restaurants, from hotels. So you can imagine that we find thousands and thousands of different substances in the arriving wastewater. Most of these components are biodegradable. Urine, feces, food residues coming from your dishwashing machine, water from the showers. It's being biodegraded, and the effluent of the wastewater treatment plant has been cleaned from those substances. Not everything is biodegradable. We have slowly biodegradable substance or non-biodegradable substance. And what happened to these substances? They just go through the wastewater treatment plant, being altered or not, and they end up in the natural environment, in lakes and rivers. That's the case of many antibiotics. That's the case of many disinfectants. That's the case of many, many chemicals. What's the issue with that? Well, they have two possible options. They can either accumulate in the environment. They're trapped in sediments, in sludge. They stay there for years, decades, not to say centuries for some substances. Or if they're not accumulating in sludge and sediments, then they are mobilized and coming back into our drinking water system. You can detect traces of all types of substances ranging from antibiotics, hormones, chemicals. There are many, many studies where they are tracing and measuring the concentration of triclosan in the water we're drinking every day. Of course, there is a safety limit, but it's there. When we think about multi-resistant microorganisms, typically we think about hospitals. In hospitals, it's creating a lot of problems. You know, it's responsible for hospital-acquired infections. There's a lot of pathogenic bacteria in a hospital. There's a high use of antibiotics. The way we are using disinfectants, the way we are using antibiotics and non-biodegradable molecules, that we are promoting the growth of multi-resistant microorganisms even in the environment. You can imagine that if you look at your city, your community, many people are using disinfectants. You must have hospitals, healthcare sectors where they're using a lot of disinfectants. You may have restaurants, slaughterhouse, food plants where they're using disinfectants. So there is a permanent pressure and a permanent concentration of disinfectant into wastewater treatment plant. And as we said, the wastewater treatment plant is a soup of microorganisms that are permanently exposed to low concentration of disinfectant. Not enough to kill them, fortunately, but enough to excite them, enough to stimulate gene transfer between microorganisms, and enough to promote the growth, multiplication of multi-resistant microorganisms. Because if you apply a pressure, it's the concept, the Darwinian concept of natural selection. You apply a pressure on a community of living organisms, then you will create conditions that will promote the growth and survival of those who are equipped to face that pressure. In our case with disinfectant, we're promoting multi-resistant microorganisms. Most of them will stay inside the wastewater treatment system, but many of them will be released in the environment. Aquatic toxicity is the capacity for a substance to be harmful to some or all aquatic organisms. We're talking about plants. We're talking about vertebrates or animals, fishes, frogs. We're talking about invertebrates, insects, worms, crustaceans, clams, mussels, all type of organisms that are all very helpful, I would say necessary for the quality of our water. Any substance that has a high level of aquatic toxicity can be harmful for the aquatic ecosystem, and then it's being harmful for the quality of our water. By definition, a disinfectant is a biocidal solution. It's a poison, and for most disinfectants, they have a high aquatic toxicity. We know this planet is all about water. I mean, us animals and humans, we're made of up to 60% of water. For plants, it ranges depending on the part of the plant or the trees, anywhere between 30% and 98%. Anything we use is released into the sewage system. Eventually, if it's not biodegradable or if it's persistent, it will end up in the natural environment and potentially eventually end up in our drinkable water. Anything that disturb or affect the water composition or its inhabitants is ultimately harmful for humankind. And unfortunately, when we talk about non-biodegradable substances or persistent substances, it's a cumulative problem. They just don't go. They stick around and they accumulate in the environment, and we keep producing them, we keep using them, and they keep accumulating, and they keep impacting on biodiversity, ecosystems, change in population, all kind of things that are not good for us and not good for any animal or plants on this planet. I'm not saying we should stop disinfecting, but we need to keep this message, to keep using disinfectant only where and when it's important and significant to use them.